Alright guys, let's talk about graphing rational functions. And this is my third video in the series. So if you haven't seen the first two, I highly recommend you watch those two before you get to this third one. In this video though, I'm going to look at rational functions in which the degree on the top is smaller than the degree on the bottom. So for example, in our example we're going to have here, I have x minus 2 on top, and on bottom I have x squared minus 4x minus 12. So the degree on top is just the largest exponent in the numerator, which is 1. The degree on bottom is the largest exponent on the denominator, which is 2. So you have a degree of 1 on top, a degree of 2 on bottom. So I'm looking at the degree on the bottom being much larger than the degree on top. So, excuse me, how we're going to work through this is kind of the same ideas as the other rational functions we look at. We're going to take this denominator and we're going to set it equal to 0 to try and solve for x. So we've done that on the other videos to try and find that center point to figure out where our asymptote's at and then figure out how to actually graph this thing. So we're trying to find the center by taking the denominator, the bottom, and setting it equal to 0 and solving. So what I have here is a quadratic, x squared minus 4x minus 12. I'm going to solve this by, not graphing, factoring. I'm looking for two numbers that multiply to negative 12. Those same two numbers need to add to negative 4. So two numbers that multiply to negative 12, but they need to add to negative 4. Those numbers are going to be negative 6 and positive 2. So my factors are going to be x minus 6 and x plus 2. Once we're factored, again, solving by factoring says take each factor, set it equal to 0, and solve. So I'm taking that x minus 6 and set it equal to 0, and taking that x plus 2 and set it equal to 0. Add 6 on this one, subtract 2 on that one. We're going to quickly learn that we have x equals 6 and x equals negative 2. Now, those are the x values of my center points that we've talked about before. I need to find a y value. Now, the y value is a little bit tricky only on these particular problems because the degree on top, again, is smaller than the degree on the bottom. So what happens when the degree on bottom is bigger than the top? Your y value, you don't need to do anything. It's just the horizontal asymptote is going to be y equals 0. So what I have here is I have two x values and one y value. So what's going to happen is I have two center points really for this graph. One of them is going to be at 6, 0, so I use that x equals 6 and I use that y equals 0. And one of them is going to be at negative 2, 0. So the x equals negative 2 and the y equals 0. So I'm going to take these 2 points and very lightly I'm going to identify where they're at. So I put very light little points there. And then I need to draw a horizontal line through them and a vertical line through them. So horizontally, there's my graph, and vertically, there's my vertical asymptotes. So there's a different asymptotes I'm working with. Now remember, asymptotes are something that my graph approaches and kind of follows along. Sometimes it crosses, sometimes it does not. So I just got to figure out what this graph looks like. Few options. I could plug in x values, try and get some y values. But the easier route is probably going to be use a graphing calculator. So what I'm going to do is I'm going to take the top, the numerator, put some parentheses around it. Take the bottom, the denominator, put some parentheses around it. And I'm going to plug those into y equals. So I already have that set up here where I put the top in parentheses, have a division sign, and then put the bottom in. And this is the graph that is turned out here. Now I'm just going to do a rough sketch. If I wanted to get highly precise, I could sit here and look at the table and try and plot a whole bunch of these decimal points. But that's a little bit too much. I'm just worried about, for what I'm doing in my class, just rough sketches. So I have a branch in this bottom left. What happens in the middle is we come down almost like a cubic function. We come down, we cross the asymptote, and then we continue on down. In the top right, we have a branch as well. So I need to be in the bottom left corner and it's pretty tight in there. In the middle, we come down and we cross and keep going down. And then we're in the top right. So up here, turn, follow the other asymptote. So what you'll find here is, unlike previous problems, we never crossed asymptotes. On this one, we did. Now, the graphs are still behaving as if they are following the asymptote. So we're very close over here along the horizontal asymptote. Then we go to the vertical asymptote. This middle graph, we go along the vertical asymptote, then go along the horizontal, and then go back to the vertical. In the top right, we go with the vertical asymptote to the horizontal asymptote. So what we're going to do is we just need to follow it up with the equations for my horizontal and vertical asymptotes, and then also identify the domain and range. So starting with the horizontal asymptote, like previous videos, we're thinking Hoy and Vux, so H-O-Y, and then vertical asymptotes, Vux, V-U-X. So these equations are going to be based off of these center points that we kind of picked out, because that's where my asymptotes are going through. So the y equals is just going to be the same y value over here. It's going to be y equals 0. For the vertical asymptote, I have 2, so I'm going to need x equals twice. For one of them, we're going to have x equals 6, which is this vertical asymptote. And for the other one, I need x equals -2, which is this vertical asymptote. So those are covered. For the domain, we're asking, hey, what x values are okay to plug into this function? Well, all real numbers are okay. So just about every single x value that you can think of, you can plug into this function and you will get an output, you will get a y value. But there are some x values we don't want to plug in. Again, it's based off where we found these asymptotes. We do not want x to be +6. We also do not want x to be -2. So the reason for this is if you plug in 6 into this denominator, you're going to get 0. And we do not want to divide by 0. We can't divide by 0. So plugging in 6, not possible here. Same deal with -2. If you plug in -2, you're going to divide by 0. We don't want that either. So all real numbers except for do not plug in 6, do not plug in -2. The range is a little bit of an interesting one because in all my previous videos we said all real numbers except the y value cannot be whatever the y value is of the center point. But that's not going to be the case here. For this type of problem, the answer is only all real numbers. The reason why a y value of 0 is okay is if you notice our horizontal asymptote, which is our y equals 0, we crossed it. So the fact that we crossed it means, yeah, it's actually okay to get y equals 0. If you plug in 2 into this equation, you're going to end up getting 0 anyways for y. So this one's a little bit different, doesn't behave like the other rational functions we graph. It is just all real numbers. So a quick summary, this was looking at the degree on top is smaller than the degree on bottom. Same kind of skill as earlier. Take the bottom, set it equal to 0, and solve. A little bit more involved because it required factoring and then setting those factors equal to 0 and solving. For the y value, pretty basic. It's just a y equals 0. Combining your x's with your y's, you get 2 kind of center points that helps you figure out where your horizontal and vertical asymptotes are at. Use the calculator to figure out how the graph is going to work. And then over here for the horizontal vertical asymptotes, same deal as always. Find the equation of your vertical asymptotes using the x values over here. Find your horizontal asymptotes using the y values over here. Domain is all real numbers except we don't want to plug in 6 and -2 because they're going to get a division by 0. And range is just going to be all real numbers. So that was my third and final video on graphing rational functions.